In this lesson, we are going to solve simple quadratic equations, and we are going to be able to put answers into simplest radical form. Please remember, inverse operations are operations that are opposites of one another. For example, when we're solving equations, if we have plus a number we want to solve, we're going to do the opposite, which is to subtract. If we were having a number being multiplied times x, in order to solve, we would divide. And now if we have a number that is being squared, we could do the opposite operation, which is to take the square root. Also remember that when you are taking the square root of 9, that could be 3 or it could be a -3, which we can more quickly write in our shortcut handwriting as plus or minus 3. So, can we take the square root of all numbers? Remember that the square root of a negative number, there is no solution in the real number system. And what we want to do in order to solve radical equations is we need to isolate or to get the x squared by itself. Just like when we're solving an equation or an inequality, we got the variable by itself. When we are going to use radicals to solve equations, we're going to want to get the x squared by itself. So let's take a look at some examples. I have x squared minus 36 equals 0. So the first thing we want to do is we want to get the x squared by itself. So we are going to add 36 to both sides of our equation, which is the opposite operation. So now we have the x squared by itself and it equals 36. Now we're going to do the inverse operation, which is to take the square root to get rid of the square. And we have to do that to both sides. So remember, a square and a square root are opposite operations, so they cancel each other. And the square root of 36 could be 6 or -6. So don't forget, we need to have plus or minus 6 as our final answer. Again, our goal is to get the x squared by itself. So the first thing we're going to do is we're going to add 98 to both sides of our equation. So we have 2x squared is equal to 98. And then we're going to divide both sides by 2 because our goal is to get the x squared by itself. So we have x squared is equal to 49. And now we're going to do the opposite or the inverse operation of squaring something, which is to take the square root. So x is equal to, the square root of 49 could be positive or it could be -7, plus or minus 7. In our next example, we have 9x squared minus 25. So we're going to add 25 to both sides. So we have 9x squared equals 25. And we're going to divide both sides by 9. X squared then is equal to, when we see we have a fraction, we want to leave it as such and then take the square root or do the inverse operation to both sides. X then is equal to plus or minus, and remember we can take the square root of each the numerator and the denominator, so we'll have 5 over 3 plus or minus the square root of 5 over 3. In our next example, we're going to subtract 6 from both sides. So we have 2x squared is equal to 0. And when we divide by 2, we know that x squared is equal to 0. The square root of 0 is 0. And then this is the only case where we do not need to put the plus or minus. In our next example, we have x squared plus 4 is equal to 0. So we're going to subtract 4 from both sides. We have x squared is equal to -4. When we do the inverse operation, which is to take the square root of both sides, we know that we cannot take the square root of a negative number in the real number system, so this one will be no solution. In our next example, we're going to subtract 5 from both sides. So we have 2x squared is equal to 90. And we're going to divide both sides by 2. And so we have x squared is equal to 45. Now we're going to take the square root of both sides, and so we have x is equal to plus or minus the square root of 45. But we have to remember to take a look at our radical and to be sure that's in simplest radical form. So if we are to make a factor tree for 45, we remember that that's 9 times 5 and 3 times 3. So since we have that pairs of 3, the 3 can come outside of the radical. So we have plus or minus 3 square root of 5. In our next example, we have x squared plus 8 is equal to 120. So we're going to subtract 8 from both sides. So we have x squared is equal to 112. And then we're going to take the square root of both sides. So we have x squared is equal to plus or minus the square root of 112. But we want to be sure that we do a factor tree. So when we do the factor tree for 8 and 12, we know that 2, I'm going to go this way, 2 and 56, and then we have 8 and 7, and we have 4 and 2, and we have 2 and 2. So when we simplify this one, we have 2 pairs of 2's right here, and we have 2 pairs of 2's right here. So we'll be able to bring 2 2's outside, so x is equal to plus or minus 2 2's would be 4, and then we have to leave our 7 underneath the radical. So our simplified version for the square root of 112 would be 4 square roots of 7. In our next example, we want to divide both sides by 3, and so we have x squared is equal to 7 over 3. Again, leave it as a fraction, don't turn it into a decimal. Now we're going to take the square root of both sides. So we have x is equal to plus or minus the square root of 7, and notice I'm going to split this into the square root of 3. Because 7 can't be divided by 3, and neither can it be simplified, we need to just make sure we rationalize the denominator. So we're going to multiply both the numerator and the denominator by the square root of 3. So we have x equals plus or minus the square root of 21 over 3 times 3 is 9, the square root of 9 is 3. That is simplified form and is our solution. Also, please remember that the 21 is under the radical and the 3 is not, so we cannot simplify it any further. In our next example, we have 8x squared plus 6 equals 9. So we're going to subtract 6 from both sides. 8x squared is equal to 3. And we're going to divide both sides by 8. So we have x squared is equal to 3/8. And then we're going to take the square root of both sides. So I have x is equal to plus or minus, and I'm going to separate these into my numerator and my denominator. I can make a factor tree for 8, 4 times 2 and 2 times 2 to simplify the denominator. So I have x equals plus or minus the square root of 3 over, one of the 2's can come outside and the other 2 needs to stay underneath. But we still have a radical in the denominator, so we need to multiply both the top and the bottom of our fraction by the square root of 2. So our final answer will be x equals plus or minus the square root of 3 times the square root of 2 is the square root of 6, and then the square root of 2 times the square root of 2 is the square root of 4, which is 2, but I already have another 2, so this is going to be a final denominator of 4. 6 and 4 look like they can both be divided by 2, but because the 6 is under the radical and the 4 is not, that is our simplified version. In review, make sure you isolate the x squared. Please don't forget your plus or minus sign in front of your final answer. Remember that you cannot take the square root of a negative number, and please be sure that your final answers are always in simplest radical form. Please complete the reflection.